In this video, we're learning about surds, or square roots in other words. Now, we already probably know a bit about surds, but we're just going to formalize a lot of that in this video. So calculating square root of 4, we'd be asking for what squared gives me 4, or in other words, I'd be finding a number a times a to be 4. That number is 2. Now, technically, there's two answers here. So we could have 2 or we could have minus 2, but square root of 4 is always considered the positive version, and the negative version we call minus root 4. Okay, root 25, what squared gives me 5? The answer is 5 there. And root 2, there's not really a nice number for that. So what we can do is we can just go root 2 on the calculator, hit the S to D button, and we get 1.41. Since I've rounded that, I'm just going to put an approximately equals 2 sign. Next, we have simplifications. Root 2 times root 3 is just root 6. You just times the numbers together. Just in case you don't believe me, root 2 on the calculator times, and then you go root 3. Even though these start off as really nasty decimal numbers that seem unrelated, they do times to give root 6. Okay, root 2 plus root 3 is already simplified though. So you cannot simplify it any further. Basically, root 2 plus root 3, we can work out what that is. We can go plus root 3. You might, so it's that number, 3.14. You might suspect that it's similar to root 6, but it is not. So root 6 is 2.44. They are unrelated. Next up, we do have division. Now, conveniently, division does just work out. So this is root of 18 over 6, or in other words, root 3. But minusing, this is already simplified. So just like plussing, you can't simplify that any further. Now, if we have the same square root and we're adding it together, you can think of this one here as, well, it's 1 lot of root 2, and then it's 3 lots of root 2. So this is 4 root 2. So this you can think of as doing like x plus 3x is 4x, if you like. So you can simplify stuff like that if the square root is the same. Next, we've got to do this. So your calculator, you'll notice if you type root 8, actually tells you in this weird form. It says 2 root 2. The reason for that is this sort of simplification process. So we want to write 8 as 2 numbers times together, one of which is a really big square number, as big as we can make it. So the square numbers are 1, 4, 9, 16, 25, 36, and so on. We notice that we can write 8 as 4 times something. That's the biggest number we can pick in that list, so we can write it as 4 times 2. So we can split this up to root 4 and root 2. Root 4 is 2, and root 2 is root 2. So that's where you get 2 root 2. Similarly, on the calculator, if I look at root 75, it says it's 5 root 3. Where it's getting that from, this is root of 25 times 3, and root of 25 is just 5. That's how you get that one there. Expand and simplify this. So with this one here, we just got to FOIL it out. So this is 8 for the first term. This is 2 root 5 for the second term. 4 root 3 for the next term. And then it's going to be take root 3 times root 5 for that last term. So if we do this, that is 8 take 2 root 5 plus 4 root 3 take root of 3 times 5. So that is root of 15 there. And that is about as good as we're going to get with that simplification there. And if the square root is the same, you get it much simpler. So 2 and 4 would give you 8 there. You would get 2 root 3 for that bit. You would get 4 root 3 for that bit. And you would get root 3 times root 3 for that bit. Yeah, the two combined together to give 6 root 3 in the middle. And root 3 times root 3 is just 3, almost by definition. So this is 11 plus 6 root 3. And conveniently, your calculator can do calculations like this. So if you get 8 plus root 3, and then if you do 4 plus root 3, we should get 11 plus 6 root 3. Sorry, my bad. That should have been 2 plus root 3 for the first bracket. Always good to double check your answers. There we go, 11 plus 6 root 3. All right, right with integer denominator. So that means no surds on the bottom. So this is 5 over root 7 normally, and your calculator can simplify it to this. The way that it's doing that When you have a square root on the bottom, you just times by that square root on the top and the bottom. So you get 5 root 7 on the top, and you get root 7 times root 7 on the bottom. Here, 3 over 4 plus root 2, you have to times by what I call the conjugate, or take root 2. So if it was a plus there, you change it to a take, and vice versa. If it was a take, you change it to a plus. You're then going to FOIL out the top and the bottom. So this is 3 into 4, and 3 into root 2 there. On the bottom, you're going to FOIL this out. Now, if you're familiar with different sort of 2 squares, then you'll notice that this is 4 squared take root 2 squared straight away. But if not, you can do the whole FOIL. So you got 16 for the first entry. Take 4 root 2 and then plus 4 root 2, which you'll notice cancel out. And then you've got take root 2 times root 2 on the bottom. So this is 12 take 3 root 2 over. The middle 2 terms cancel out there, and you'll be left with 16 take 2. So this is 12 take 3 root 2 all over 14. And I'm really hoping your calculator can do this as well. So 3 over 4 plus root 2. Let's see, 12 take 3 root 2 over 14.